Here we are, episode 25, breaking down the basics. This is the long form of safeguards. We're talking about mechanical safeguards. All right, so we'll follow up with some examples from the earlier video. So number one, we're just talking about a couple different mechanical safeguards. Number one, we're looking at check valves. And you can see here, we're showing you two different types of check valves. All right, so a two different type of check valve design is what you're going to want to have the most conservativeness and basically have the safest, kind of most reliable check valve setup. You're looking at the P&ID now, and you can see on a P&ID it's going to be noted as these are actually the same. So you may want to make a note, like a note 1 or note 2 or whatever at the bottom to say, hey, these are dual dissimilar check valves, and they're in line with one another, and maybe you can show the design or note the manufacturer for each one. Okay, secondly, we're looking at restrictive orifices. All right, so as you can see on the P&ID, this is denoted on a system that is on a nitrogen system, and it's used for a utility to limit the amount of nitrogen capacity that can go into this vessel, and there's a relief device on the vessel, right? So they size the relief device on the vessel with this orifice in mind to make sure it's restricting the capacity that's flowing through the system, and it's a key point. We want to make a note and make a note there to denote that is how this was sized. And you can see they have noted on here that this is sized for 500 SCFM. All right. So the third one that we're looking at here for safeguard mechanical is mechanical stops. And you can see a diagram here looking at the inlet of a valve. And what that stop is going to do is it's going to change the amount that the spring can either compress or lift, which is going to adjust then, as you can see, the valve position, right? So you're going to put a mechanical stop depending on which way you want it to go, how that design is going to depend. But basically, it's going to butt up against the part of the valve that's stopping the spring, like we said, from compressing more or decompressing all the way. And as you can look at that valve, you can see there's still an ability to have flow through there, right? So these are going to be in situations where closing a valve all the way or stopping something all the way is an undesired consequence, or having a valve fill wide open too quickly is going to be an undesired consequence. We mentioned a little bit as well, this can also factor into certain mechanical devices that help the time in which it takes a valve to open. That's going to help you in a surge consequence, leading to, we think of water hammer or overpressure. As always, more long-form contents can be seen on our YouTube channel and our website. Hope you like it. Safety Made Simple, Bayer Process Safety, keeping you safe.